Hi guys, my name is Alexandra Hoya from ECE 31 of De La Salle University Dasmariñas, and today I'm going to do an experiment entitled The Universal Gates for my digital electronics subject. Before we start on our experiment, let's have a little background about the topic that this experiment tackles. Given that there are many digital circuits that has only the three basic digital elements, which are the on, or, and not, most digital equipment are implemented with versions of these circuits known as NAND or NOR gates, or the universal gates. Basically, these are AND, OR, and NOT gates combined with an inverter. The universal gates are essential since they are the most widely used type of digital logic elements. This is because they offer numerous advantages over simple gates considered earlier. The term NAND is contraction of the expression not AND. A NAND gate, therefore, is an AND gate followed by an inverter. The NAND output is simply the complement of the AND output. The term NOR is a contraction for the expression not OR. Therefore, NOR gate is essentially a circuit combining the logic functions of an OR gate and an inverter. The materials and equipment needed for this experiment. One 7408 ON gate, a 7400 NON gate, a 7402 NOR gate, a 7404 hex inverter gate, a 7408 ON gate, a 7432 OR gate, a power supply with a 5-volt output, an LED, a resistor with a 360 ohm resistance, a breadboard, connecting wires, and a long nose or flyer. For part 1, examining the basic operations of NAND gate. This is how you form the NAND gate circuit. For part 1, when both inputs A and B are 0, output is 1. When only B is 1, output is still 1. When only A is 1, output is still 1. When both A and B are 1, output is 0. Part 2, combined ON-NOT operations. This is the circuit diagram of a ON-NOT combinational circuit. So this is how you construct the diagram. For the results of the combined ON-NOT operation, when both of the input terminals are 0, output is 1. When only B is 1 and A is 0, output is 1. When only A is 1 and B is 0, output is 1. But when both of them are 1, output is 0. It was observed that the output terminals for 2.1 and 2.2 are the same. OR operation using NAND gates. This is the logic diagram of OR operation using NAND gates. To construct the diagram, so the results of OR operation using NAND gates shows that when both input terminals are 0, output is 0. And when only B is 1, output is 1. When only A is 1, output is 1. And when both A and B is 1, output is 1. The results for table 2.3 shows that when only one input has 1, output will automatically become 1. This is because it is a OR operation using NAND gates. Part 4. AND operation using NAND gate. This is the circuit diagram of a AND operation using NAND gate. This is how you construct the circuit diagram of AND operation using NAND gates. The results of AND operation using NAND gates show that when both of the input terminals are 0, output is 0. When only B is 1, output is 0. When only A is 1, output is 0. And when both of the input terminals are 1, output is 1. The results of tables 2.1 and 2.4 shows exactly opposite output results. Part 5. NOR operation using NAND gates. This is the circuit diagram of a NOR operation using NAND gates. This is how you construct the circuit diagram for NOR operation. The results of NOR operation using NAND gates show that when both terminals are 0, output is 1. And when only input B is 1, output is 0. When only input A is 1, output is 0. And when both inputs A and B are 1, output is 0. Part 6. OR operation using NOR gate. This is the circuit diagram of a OR operation using NOR gate. This is how you construct the circuit diagram. The result of OR operation using NOR gate shows that when both inputs A and B are 0, output is 0. When B is 1, output is 1. When A is 1 and B is 0, output is 1. When both A and B is 1, output is 1. The results of table 2.6 shows that when there is one input that is 1, output will be 1. This is because it is an OR operation using NOR gates. Part 7. AND operation using NOR gate. This is the circuit diagram for AND operation using NOR gate experiment. This is how to construct the circuit diagram for part 7. The results of part 7 AND operation using NOR gate shows that when both inputs A and B are 0, output is 0. When only B is 1, output is still 0. When only A is 1, output is 0. But when both A and B is 1, output is 1. The result of part 7 of this experiment shows that when one of the input terminals is 0, output will be 0, and an output of 1 will only be possible to a AND operation using NOR gates when both inputs are 1. Part, part 8. NAND operation using NOR gate. This is a circuit diagram of a NAND operation using NOR gate. The result of NAND operation using NOR gate show that when both A and B is 0, output is 1. When only B is 1 and A is 0, output is still 1. When A is 1 and B is 0, output is still 1. But when both of them is 1, output is 0. The result of NAND operation using NOR gate is the same with the results of single NAND gate because they both use NAND gates, which are logic gates that produces only an output that is false if all of the inputs are true. And in this case, both of the tables that has two inputs as one had false outputs. From the results of this experiment, it can be concluded that AND, NOT, and OR gates are the basic gates, and we can create any logic gate or any Boolean expression by combining a mixture of these, thus the universal gates. Non-gates have a particular property that any one of them can create any logical Boolean expression as seen in this experiment, meaning that you can create any logical Boolean expression using only NOR gates or only non-gates. It should also be noted that other logical gates do not have this property. With this, it can be seen that the main advantage of the universal logic gate is that it can be used to make any kind of logic gate. Logic gates are used in our everyday electronic devices such as TVs, computers, and telephones. For my recommendation, I can say that it is essential to first learn how to understand the circuit diagram and the positioning of the pins of an IC to be able to do this experiment more easily.